Hello? Oh, hi there. Sorry, I thought I was alone for a second. Now that you're here, I see that's not the case. However, I got to thinking, are we alone? I don't necessarily mean you and I. Perhaps there are others nearby, maybe even watching this video with you. But I mean we. Earth. Civilization. Humanity. Are we alone? I've asked myself this question quite a lot, and frankly, we've been asking ourselves this question since humanity first walked the earth. So I've compiled my thoughts and some exercises into this video, and if you'll accompany me, perhaps we can explore this question together. Are we alone in the universe? Now, unlike most questions in science, this question might actually have a simple answer. Yes, there is other life out there, or no, there isn't, both of which seem rather terrifying. Say there isn't life out there. Maybe we are alone in this universe. That means there's nothing really going on. It's just us, just some stars, planets, and chunks of rock floating around, maybe some light bouncing off here and there. A universe without much life is boring. Let's say the contrary is true. Maybe there is life out there. Well, that could also be quite terrifying. What is out there? Will we ever find it? And what will they think of us? That can also be quite scary. Or it can be quite motivating. In my opinion, a universe teeming with life is fundamentally more exciting than a universe with none. I would like to get my hopes up and think that there is life out there, but we'll never know for sure unless we continue looking. So, how do we quantify how much life could be out there? Around the year 1960, American astronomer and astrophysicist Frank Drake was conducting some research at the National Radio Astronomy Observatory in Green Bank, West Virginia. His research was related to SETI, the search for extraterrestrial intelligence. Frank was looking for intelligent signals arriving at Earth, but unfortunately he was unsuccessful in his research. After his telescope time concluded, Frank held a meeting with other SETI members where he presented his results. As he prepared, he created an equation to use as a tool for estimating how much life could be out there. At the time, he didn't think much of it, but it turns out we can use his very equation for our own cosmic estimation. So here it is, the Drake equation. Now before you get scared off at the sight of math, no worries, I've put together a page on my website that does all the multiplication for you. All you have to do is make some estimates. So here on the SciSky website, there is a page where you can modify numbers and view how many civilizations there could be for that combination. I'll leave a link in the description. And if you like your results, be sure to post it down in the comments below and I'll take a look at it. The Drake equation consists of a few variables that we multiply together to find an end result. The variables are n sub star, which is the number of stars in the Milky Way galaxy, f sub p, which is the fraction of those stars that have planets around them, n sub e is the average number of planets that can potentially support life per star that has planets around it, f sub l is the fraction of planets that could support life and actually develop life at some point, f sub I is then the fraction of planets that life actually becomes intelligent, or civilizations. F sub c is the fraction of those civilizations that develop technology capable of detecting radio waves and projecting their existence into space. The final variable L is the length of time for which such civilizations release those signals into space. Now, if we try to put values to these variables, some are easier than others. First, n sub star is modern estimates put it around 400 billion. F sub p is about a quarter, meaning 1 in 4 stars have planets around them. This is results of our current technology. N sub e is probably about 2. If we look at our solar system, Earth and Mars are now or have been capable of supporting life at some time. F sub L is a little bit more difficult to estimate. We will use about a half in our exercise, just as a starting point. Now, the variables start to get much more difficult to estimate. For simplicity, we will set f sub I and f sub c to 1 in 10. And now finally, L is among the most difficult to estimate in this equation. I will say for now that a civilization could last 1/millionth of the time that the universe has been going on. So that's 1 over 1 million. Now, we have all of our values and we can multiply them together. And for this example, we find that the number of civilizations in our galaxy that are capable of communicating with us right now is 1,000. Being optimistic, the numbers could work out to give you 1 million civilizations capable of communicating with us right now. Even before the Drake equation came to be, we held similarly optimistic thoughts. Around the year 1950, Enrico Fermi asked himself, if the odds of extraterrestrial intelligence are so large, then where are they? Why haven't they visited Earth? And thus was born the Fermi Paradox. Perhaps there is some great filter that prevents life from reaching intelligence, or maybe life is so common that they prevent detection until a new civilization finds a way to leave their home star. The YouTube channel Kurzgesagt has excellent videos about the Fermi Paradox. There are many opinions about the Fermi Paradox, and I'm curious what your thoughts are. Be sure to let me know in the comments below. Until we find an answer, we will surely be pointing our radio telescopes to the sky to listen. Even when some research may seem unsuccessful, some great things can result. So we can sit idly by and wait for signals to reach us, or we can call out and see if anyone else in the cosmos is listening. Hello? Hello?